what is design, so what is the importance of design, so what are the things we are following in the design, how to identify the problems in the design, how to understand the problems, okay, how to identify the solutions, and how to describe solution abstraction, okay, now, and also what is the architecture in the life cycle, okay, now what are the approaches we have to see, top down approach, bottom up approach, and object oriented approach. Okay, those things we saw in the last class. So very important thing is architecture in the life cycle. Okay, now we also know that what are the phases we are having in the particular architecture. Okay, now we saw different types of phases, and also we know the phases having the internal relationship. So and also they can having the interfacing together from one phase to another phase. Why? Because the second phase input is depends upon the output of the first phase. Okay, these are all the things we saw in the last class. Okay, na? So for this, for example, we discussed about SDLC, software development life cycle. So what is the importance of SDLC to develop a particular project and particular product, whatever it may be. So for before going to design something, we need to we need to consider some modules and some phases according to that. So based on that, we need to plan how to make it. So that's why we can follow the SDLC to develop any software programs, but different types of models we are using to develop SDLC, that is another concept. First we need to consider the basic steps, we need to follow the basic phases, we need to follow the particular designing phase and all. So according to that, we are using different types of models to develop a particular projects or particular product. So here we are going to develop the software system. For example, we have to imagine we are going to develop a software system and nothing but regarding to the architecture. So we are going to design an architecture, software architecture is related to the fundamental structure of the software. Okay, na? So in inheritance, it is the main thing is we are going to develop the software system. So before going to develop the software system, we make the software architecture. So we are going to design the software architecture. We are following some different types of models and methods, whatever it may be. Here also we are using one better model or better method we are following here, that is called ADD. Okay, attribute driven design. ADD is nothing but attribute driven design. This is a very important method or approach to designing the architecture to satisfy here the both quality requirements and functional requirements. So we are going to design an architecture, it's mainly depends upon the requirements. Okay, now we are collecting the requirements. According to the requirements, we make the analysis. According to the analysis, they are going to design phase 1 and design phase 2, detailed design. So here that we are going to doing this again and again. So according to this, we can call it as everything. So that is the very importance of software design. It's going to be satisfies the requirements, quality requirements and functional requirements. Okay, now so that's why we are using this ADD method. We want to satisfy both the quality requirements and functional requirements. We are choosing the best method or approach, that is ADD. It takes input set of quality attribute scenarios and employs knowledge about the relationship between quality attributes and achievement and the architecture in order to design the architectures. So here it will be considered the all quality attributes as an input. Based on that, it will be processed and it can be put into the order to design an architecture. So the ADD method can be viewed as an extension to most other development methods. So, already some existing methods we know. So, in the SDLC we are having waterfalls models, increment models. In the software engineering we learn different types of models, RAD model and spiral models like. So, better than to these ADD is better than to the particular those models. So, why it is better than, what is the speciality we are having this particular ADD model we have to see. And so, development methods such as the relational unified process, it is nothing but relational unified process. Okay, na? So, relational unified process is nothing but it has the high level design plan, it has the high level design plan. This high level design plan is also follow several steps, in the detailed design and implementation, So, this is the one type of recursive method, already we know that what is recursion. Okay, na function calling itself and man programmatically ga cheppukondi. Here also some of the functions are repeated to each and every module or submodule or subsystem. So, this is very important here. So, that's why it is a rational unified process. The ADD is the rational unified process. So, the rational unified process has several steps that result in the high level design of an architecture, but then proceeds to detailed design and implementation. So, here it conducts a very detailed design. Based on the detailed design, it is going to be implemented. So, that is the very importance of this ADD rather than to comparatively other approaches or methods. Okay. The incorporate ADD into its involve modifying steps dealing with the high level design of the architecture, and the following process has described by rational wise. Okay, na? So, here we need to follow the rational wise process. The ADD is an approach to defining software architecture that based on the decomposition process, on the quality attributes the software has to fulfill. Okay, na? It's the main thing, the main approach of this ADD is it is defining software architecture. So, based on the decomposition process, is nothing but for example, I want to say here decomposition is nothing but so the main program is going to divide into subprograms. The subprograms are going to divide into subtasks. For example, according to programming language. So, according to the architecture, we can call it as what is decomposition is nothing but the system is going to divide into subsystems. The subsystems are going to divide into submodules. Okay, now here the system is also follow the all rules while designing the architecture. The subsystems are also individually have the follow the other same rules recursively, and the submodules also follow these methods recursively. So, and every piece of work it is going to see all approaches, okay, now how it works. So, it is going to be applied to the entire system. These all steps are going to be applied to the subsystems. Again, these all are applied to the individual submodules. Okay, na? So, this is the thing here we need to follow. That is the meaning of recursively. Okay, na? We are done different levels of approaches here according to the system, according to the subsystem, according to the submodules. That is the meaning of decomposition process. Yes, and the quality attributes to fulfill the particular software. So, it is a recursive decomposition process where at each stage statistics and technical patterns are chosen to satisfy a set of scenarios, and then functionality is allocated to the initiate the module types provided by the patterns. So, how we can satisfy these all statistics? Statistics means ideas, design ideas. Okay, na? So, stages, each and every module stage, we can apply the different types of statistics. So, with the help of architectural patterns. So, how we will design these all architectures means by following some patterns. Okay, now what are the patterns we will see in the next classes. Okay, now, so by using these better patterns, architectural patterns, so we need to apply different types of ideas. Statistics means designs, design ideas. So according to the each stage, okay, we need to apply according to each stage. So that is the meaning of recursively approach. That is the meaning of decomposition is the one point, and also we can apply all steps in the particular each and every stage, and we need to apply different types of ideas, that is called statistics, on a particular, and also along with the particular architectural patterns are chosen to satisfy the quality scenarios. So why you are chosen these? We need to satisfy the quality scenarios, so quality attributes and functional both, and then functional. So when the quality attributes are perfect, automatically the system, every system functionality will be good. So that's why we need to focus first on quality attributes, then it will be focus automatically we can achieve the functional requirements. That is the logical thing here is allocated. And the ADD is positioned in the life cycle, okay na. So we are having the life cycle, every architecture is having its life cycle, okay na. So here also we are having our architectural life cycle, as I saw in the previous class, okay na. So where this ADD approach is applicable, from which phase, from which module in this particular software architectural life cycle is nothing but, so after requirement analysis. So where we are when we are applying this ADD approach, after requirement analysis, okay na, we are applying, we can follow this ADD in a particular life cycle. So first we can collect the requirements, then we can focus on requirement analysis. So after the thing we can design, yes ma, after then we can design. So from this phase we are applying this particular approach, ADD approach. That's I said. ADD is positioned in the life cycle after requirements analysis, and as well as said can begin when the architectural drivers as shown with the confidence, okay now. The output of ADD is the first several levels of modules decomposition view of an architecture and other views as appropriate. So first how we expect the output of ADD means according to that decomposition process, అంటే ప్రతి మాడ్యూల్కి మనం ఫస్ట్ అవుట్పుట్ని ఎక్స్పెక్ట్ చేస్తాము. సో ఎందుకు అంటే ఫస్ట్ మాడ్యూల్ అవుట్పుటే సెకండ్ మాడ్యూల్కి ఇన్పుట్ కాబట్టి. సో ఫర్ అకార్డింగ్ టు దట్ ఫస్ట్ వీ కెన్ వ్యూ the output, we can expect the ADD output for individual units or for individual modules or sub modules or subsystems, whatever it may be. Then we can get the appropriate output, okay na. That is when we can interface together, when we can combine all those modules, we can get the overall result reports, okay na. Then that is called as a results generation or report generation. So we can focus on individuals. So later on we will get the overall output, we will, when we combine all phases together, so then we will get the appropriate output, okay now. And so first we can expect on level wise, then we can combine all those things, then we can get the appropriate results. So not all details of the views result from an application of ADD. So the system is described as a set of constraints of functionally and interactions among them. So why we can follow these views not in detailed wise ante, so according to that decomposition process. So as I said in the previous, so it can be first view the approach on module wise, okay na. So when we focus on module wise, so we will get the clear details, ఓకే నా. ఓవరాల్గా మనం ఒకసారిగా ఓవరాల్ సిస్టమ్ మీద మనం కనుక ఈ డిజైనింగ్ అప్లై చేయాలి అంటే వీఆర్ నాట్ గెట్టింగ్ ద అవర్ గుడ్ రిజల్ట్స్, వీఆర్ నాట్ గెట్టింగ్ గుడ్ రిజల్ట్స్. దట్స్ వై వీ కెన్ అప్లై ద వ్యూస్, we can apply the decisions, we can apply the statistics, design decisions on each and every modules. So then we can add, then we can interact together, that is called interactions among them, okay na. Then we can get the different types of functional qualities, so according to the constraints. So that's why we can focus on individual, then we can interact together, that is according to the interactions. So then we can combine all those things, finally we can get the best results, okay na. Until then we are not expect the good results when we design overall system at a time. So that's why we can decompose this our entire the system modules, we can break them into entire the system into subsystems, and entire the subsystems are going to divide into sub modules. So, we can apply these statistics and design architectural patterns and this particular each and every stage, then we can get the better results. So, then we can interact together, then finally, we will get the appropriate results according to quality requirements and according to the functional requirements. That is the main importance of ADD, and it is a critical for achieving desired qualities. So, and it provides a framework for achieving the functionality. So, overall it will be difficult to get the desired qualities, and desired means expected qualities. So, what we need to get, how we need to get desired qualities, and it provides framework for achieving the functionality. So, what is framework? Generally it is an umbrella activity. Framework is nothing but what ma? It is an umbrella activity. What is an umbrella activity? We are having step by step procedure. We are having step by step procedure. We are following step by step procedure. Okay, now for each and every module we can repeat again and again the same steps. Okay, na? That is called an umbrella activity. That umbrella activity is called as an framework. When you follow the framework, definitely we will get the better achievement and better desired qualities, so according to the functionality. So, the difference between the architectural resulting from ADD and one ready for implementing rest in the more detailed design decisions that need to be made. Okay, now we can apply more design decisions. So, when we are want to make different types of architectures, these could be, for example, the decision to specific object oriented design patterns, or a specific piece of middleware that bring with the many architectural constraints. So, ఈ డిజైన్ ప్రొసీజర్లో మెయిన్గా మనం ఏం యూస్ చేస్తాము, రేషనల్ రోజెస్ అంటే యూఎంఎల్ యూనిఫైడ్ మోడలింగ్ లాంగ్వేజ్ టూల్స్ ఏవైతే ఉన్నాయో అవి యూస్ చేస్తాము. యూనిఫైడ్ మోడలింగ్ లాంగ్వేజ్కి వాట్ ఆర్ ద టూల్స్ వీఆర్ యూజింగ్? రేషనల్ రోజెస్ టూల్స్ యూస్ చేస్తాము. విత్ ద హెల్ప్ ఆఫ్ దిస్ రేషనల్ రోజెస్ టూల్స్, దట్ ఈస్ ద మీనింగ్ ఆఫ్ ఆబ్జెక్ట్ ఓరియంటెడ్ డిజైన్. Object oriented design. In this design phase, so we will say the relationship among the particular modules. We can say the relationship among the particular user and end user with the particular system. So, with the help of use case diagrams we can say this. So, here the object oriented design, that is called what ma? Object oriented design. Here when we achieve the quality attributes, then we can achieve the functional attributes. So, that is the main thing here. So, how we achieve this, how we will get the quality attributes means when the end user is interact with the particular machine or particular system, so he feel it is better, he feel while working he feeling it is better to work, it provides a good quality. So, it gives a good functionality, he feels. So, how he feels? According to interaction, how the user is better interact with the particular system, then it will be very easy to say that it is a provide good quality attributes and it provides a good functional attribute. Until that it is not a better interaction to the particular user. You get this, you are following these all design decisions, okay na, with the help of ADD steps. So, here we need to use object oriented design patterns, okay na. So, a specific piece of middleware. Middleware is nothing but what ma? So, here we are following this entire system. So, this system containing subsystem. So, we can apply these all things to the particular subsystem, that is called middleware according to this architecture. So, that brings to the many architectural constraints. So, why we need to means it brings many architectural constraints. Constraint means what ma? Views. Okay, these are related to the stakeholders. These are views or constraints are related to the by considering of all different types of stakeholders. Okay, na? And the architecture design by ADD may have or internally deferred this decision to be more flexible. So, whatever the thing, what is the main intention? Intentionally we can get the more flexible. When you using this particular system, we will get more flexible. Okay, na? That is main the importance of design. It is the that is the system is flexible or not, the software system is flexible to the users or not. So finally that is the result. For that we need to follow this all scenarios. So here we demonstrate the ADD methodology by using to design a product line architecture for a garage door open within a home information system. Here they are taken one real time example. So what is exact design? So how we can focus on the particular design? So మనం ఒక థింగ్ ని డిజైన్ చేసేటప్పుడు మనం ఎలా మనం ఫోకస్ చేస్తాము ఆ డిజైనింగ్ మీద అని చెప్పడానికి. సో హౌ ఇట్స్ ఫ్లెక్సిబుల్ అని మనం we found how this is flexible అని మనం చెప్పడానికి. సో they are taken one real time example, that is called garage door opener within a home information system. Garage door means what? The car garage door. Car garage door, for example, car garage door opener within a home information system. So okay, now that is the real time example they are taken. The opener is responsible for raising and lowering the door via a switch. ఇక్కడ who is the person, who is the responsible person? Opener. And ఎవరు? end user. Opener means what ma? End user. So the end user is responsible for raising and lowering the door via switch. Okay na? Through a switch, later on it is a remote control. Next architecture same వచ్చినాయి, ఇనిషియల్ గా స్విచెస్ ఏ కదా మనం యూస్ చేసాం. ఓకేనా? లేటర్ ఆన్ రిమోట్ కంట్రోల్స్ వచ్చినాయి అకార్డింగ్ టు దిస్ అప్రోచ్. ఓకేనా? సో raising and lowering is nothing but, so open and close according to this example, open the doors and close the garage doors, and that is the meaning of raising and lowering. So via switch or remote control. So initially through a switch aina cheyochu manamu raising or lowering, లేదా through a remote control చేయొచ్చు or the home information system. సో మనం ఇంట్లో ఉండి కూడా దీన్ని ఆపరేట్ చేయొచ్చు అకార్డింగ్ టు ద పర్టికులర్ డివైసెస్. ఓకేనా? సో హియర్ లైక్ దిస్ వీ కెన్ ఆపరేట్. సో ద మెయిన్ రెస్పాన్సిబుల్ పర్సన్ ఈజ్ who are raising and lowering, that is called opener. Okay na? He is maybe following via a switch or remote control or the home information system. So whatever the method you need to follow, he is the responsible person raising and lowering the car garage doors. Okay na? So మనం మాన్యువల్ గా లిఫ్ట్ చేయడం కాదు, మాన్యువల్ గా ఓపెన్ చేసి మాన్యువల్ గా క్లోజ్ చేయడం కాదు. We can operate, we are in particular somewhere else, so we can operate. Okay na? When we want to open means raising the door, when we want to lowering the door, we want to close the door. Okay na? So this can be like this, the architectures will going to develop design today according to the considered to the previous systems. Okay na? So that is the better example here they are taken. So it is also possible to diagnose problems with the opener from within a home information system. So diagnose means what ma? So it tests the problems. So designing is not only for opening the system and closing the system. So meanwhile when they are raising and when they are lowering, okay na, there are some problems will also get, technical problems will also appear. So which type of technical problems we will saw in the next points. Okay na? So in these situations also when the problems are occurred meanwhile, so we need to solve, we need to diagnose them. The architecture is going to be diagnose those problems. So with the opener from within a home information system. So how we can diagnose the problems? I mean, how we can test the problem? Diagnose means test the problems. How we need identify the problems, how we need resolve the problems. So based on consideration of all those constraints, we need to design a system. So when meanwhile the problems had occurred, so we can resolve them immediately. So in like this they can design the particular garage door opener systems. Okay, now like this we can develop the software architectures. So when the problems will occur, we can diagnose them. Okay na? That is the main thing. That's why the ADD provide this type of approaches. So for example, so for our garage door example, the quality scenarios include the following. So what are the main things, what are the quality scenarios we are following to our real time example, garage door example. So here the device and controls for opening and closing the doors are different. for the various products in the product line. According to the products, these are different. So, for closing the door and opening the doors, okay na. So, in the product line. So, as already mentioned, so they have include controls from within a home information system. సో వాళ్ళు ఇంట్లో నుంచి అయినా హోమ్ ఇన్ఫర్మేషన్ సిస్టమ్ ద్వారా అయినా వాళ్ళు కంట్రోల్ చేయొచ్చు. ఇంకా 2 ఆప్షన్స్ చెప్పాము, ఏంటది, రిమోట్ కంట్రోల్ ద్వారా అయినా వాళ్ళు ఆపరేట్ చేయొచ్చు, లేకపోతే త్రూ ఏ స్విచ్ ద్వారా అయినా కానీ వాళ్ళు ఆపరేట్ చేయొచ్చు, ఓకేనా. సో ద ప్రోడక్ట్ ఆర్కిటెక్చర్ ఫర్ ఏ స్పెసిఫిక్ సెట్ ఆఫ్ కంట్రోల్స్ షుడ్ బి డైరెక్ట్లీ డిరైవబుల్ ఫ్రమ్ ద ప్రోడక్ట్ లైన్ ఆర్కిటెక్చర్స్. సో ఉచ్ ప్రోడక్ట్ ఆర్కిటెక్చర్స్ ఆర్ స్పెసిఫిక్ సెట్ ఆఫ్ కంట్రోల్స్ ఉంటాయో వాటిని మనం ఫాలో అయ్యి, ఆ రూల్స్ ఫాలో అయ్యి దే కెన్ డిజైన్ ఏ పర్టికులర్ ప్రోడక్ట్ లైన్ ఆర్కిటెక్చర్స్. హియర్ ద ప్రాసెసర్ యూజ్డ్ టు డిఫరెంట్ ప్రోడక్ట్స్ విత్ డిఫరెంట్ స్టాటిస్టిక్స్. సో ఈ ప్రాసెసర్స్ అనేవి ఏవైతే వర్క్స్ ఆన్ ప్రాసెసర్స్ ఉంటాయో దే కెన్ బి అప్లైడ్ ఆన్ డిఫరెంట్ టైప్స్ ఆఫ్ products. So according to this we can follow these things. So here suppose we can take the product architecture for each specific processor should be directly derivable from the product line architectures. If a abstract is nothing but ఈజ్ ఎ పర్సన్ అయి ఉండొచ్చు, ఇట్స్ అన్ ఆబ్జెక్ట్ అయి ఉండొచ్చు. మనకి ఎక్కడ ప్రాబ్లమ్స్ వస్తాయి, యూజర్ ఇంటరాక్ట్ అయ్యేటప్పుడు ఏదైనా ప్రాబ్లమ్స్ రావచ్చు, లేకపోతే ఏదైనా త్రూ ఆబ్జెక్ట్స్ ద్వారా మనకి ఏమైనా ప్రాబ్లమ్స్ రావచ్చు. ఈజ్ అన్ అబ్స్ట్రాకిల్, ఇఫ్ దేర్ ఎనీ అబ్స్ట్రాకిల్స్ ఈజ్ డిటెక్టెడ్ బై ద గ్యారేజ్ డోర్ డ్యూరింగ్ descent, it must halt within 0.1 seconds. So alternatively reopen if any problem is occurred. So how we can set this particular design system? So this problem is resolved within fraction of seconds. They mentioned statistically within 0.1 second it can be alternatively reopened. When the problem is occurred, when it will going to struck this particular system, so automatically when the obstacles are came through the particular person, through the particular object, so it automatically reopens within the fraction of second, that is 0.1 seconds. So like this they are designed the particular garage door system, okay na. So during any problem is occurred, so now automatically it's going to be reopened, okay na, within fraction of 0.1 seconds. So when the obstacles is occurred by either person or through an object, like this they are designing, okay. So that is called diagnose. When the problems is occurred through the persons, by mistake we are pressing any wrong buttons, like automatically it's going to be. So then where the problem is diagnosed, so automatically the system is reopened. Alternatively it can be going to reopen, okay na? That is the main importance of this particular design, okay na? Like this they are going to design. So the garage door opener should be accessible for diagnosis and administration from within the home information system using a product specific diagnosis protocols. So we want to identify these problems, we want to administrate this particular home information system through a home information system. We can use this particular diagnosis protocols. We are following some rules, so how we can test the problems, how we can resolve the problems. So protocol is nothing but rules. We can follow some rules. Based on those rules, based on those statistics, they can design the particular garage door system, okay na. It should be possible to directly produce an architecture that reflects these protocols, okay na. It directly produces particular architecture according to these protocols. So like in this ADD, so how we can begin the steps while designing the architecture, how we can begin this ADD method or approach. So that is the first one is beginning step. First one is what ma? Beginning step, that is called beginning ADD. So what we can see here, we have already introduced architectural drivers. ADD depends upon identification of the drivers and can start soon as all of are known, okay na. According to the drivers we can the ADD depends upon the identification of the drivers and can starts, okay na. So first step, ADD steps. Here we can follow these steps while designing a architecture, while designing the particular products and whatever it may be, we can follow these ADD steps. The first, choose the module to decompose. As I said in the previous, first మనం ఏం చేయాలి, ఎంటైర్ ద స్ట్రక్చర్ని లేకపోతే ఎంటైర్ ద ప్రాబ్లమ్ని వీఆర్ గోయింగ్ టు డికంపోజ్. సో ఎలా డికంపోజ్ చేస్తామో కూడా చెప్పాను. సిస్టమ్స్ వైజ్గా చూడాలి, సబ్ సిస్టమ్స్ వైజ్గా చూడాలి, సబ్ మాడ్యూల్స్ వైజ్గా చూడాలి. డిఫరెంట్ అప్రోచెస్ని మనం ఫాలో అవ్వాలి టు బెటర్ క్వాలిటీ attributes or to better functional requirements. That's most important thing in the ADD steps. First step, choose the module to decompose. So ఏ మాడ్యూల్స్ మనం చూస్ చేసుకోవాలి. సో ఆ మాడ్యూల్స్ని చూస్ చేసుకుని డికంపోజ్ చేయాలి. అవసరమైతే వాటిని మళ్ళీ మనం మాడ్యూల్స్గా చేయాలి, సబ్ మాడ్యూల్స్గా చేయాలి, సబ్ సిస్టమ్స్గా చేసుకోవాలి, సబ్ మాడ్యూల్స్గా చేసుకోవాలి. అకార్డింగ్ టు ద రిక్వైర్మెంట్స్ బేస్డ్ ఆన్ కన్స్ట్రైంట్స్, these can be going to divide the modules in different scenarios. Here you can see the first step. The module to start with usually the whole system. General గా ఒక మాడ్యూల్ అంటే మనం ఎలా కన్సిడర్ చేస్తాం, ఫస్ట్ ఇందులో ఈ సబ్ మాడ్యూల్స్ ఉన్నాయని చూడడం కంటే ఎంటైర్ ది సిస్టమ్ని మనం ఒక మాడ్యూల్ లాగానే చూస్తాం ఫస్ట్. సో దెన్ ఓన్లీ వీ కెన్ ట్రై టు లెర్న్. సో వాట్ ఈస్ దిస్ సిస్టమ్? సో వీ వాంట్ టు డిజైన్ దిస్ సిస్టమ్, హౌ టు సెపరేట్ దిస్ సిస్టమ్ టు గెట్ బెటర్ ఈజీ appropriate results. So then we can share the work. Okay, now then we can divide the work and share the work, okay, according to the team members, whatever it may be. So first we can see the whole system. All required inputs for this module should be available. So all requirements are available according to this module, or we can see. So the requirements available is nothing but according to the constraints, according to the functional requirements and according to the క్వాలిటీ రిక్వైర్మెంట్స్. ఓకేనా, ఇక్కడ ఫస్ట్ మనం ఒక ఆర్కిటెక్చర్ని, ఏ ఆర్కిటెక్చర్ని మనం డిజైన్ చేయాలన్నా మనం ఫస్ట్ కన్సిడర్ చేయవలసిన 3 థింగ్స్. కన్స్ట్రైంట్స్ రిలేటెడ్ టు ద స్టేక్ హోల్డర్స్ చూడాలి. సో అకార్డింగ్ టు ద రిక్వైర్మెంట్స్. సో బేస్డ్ ఆన్ దిస్ వీ కెన్ ఫాలో ద ఫంక్షనల్ రిక్వైర్మెంట్స్ అండ్ క్వాలిటీ రిక్వైర్మెంట్స్. దట్ ఈస్ మస్ట్ అండ్ షుడ్ హియర్. So we can consider these 3 things. We can decompose the modules. Okay na. Next, second step, refine the modules according to these steps. Refine the modules according to these steps. And enti modules malli we can refine. Okay na. So how we can refine these modules in according to these steps means, choose the architectural drivers from the set of constraint quality scenarios and functional requirements. According to quality scenarios, according to functional requirements, we can view these particular modules. The steps determine what is important for this decomposition. So ikkada while decomposing this we can remind always, so what is the importance of decomposition? You know, while examining these things we can design properly. Okay na. So which type of abstractals is occurred in a particular model according to this design. So how to resolve the particular abstractals problems, so how to diagnose them, that is very easy. When we refine the modules, it is easy to help us how to diagnose the particular problems and how to resolve the abstractals. So that's why we can refine the modules in the second step. In the second step we are having sub points. Okay, now refine the module step, we are also having some sub points. What is the sub point? Choose an architectural patterns. So first we want to refine the modules, we can select one style. సో ఈ స్టైల్లో నేను డిజైన్ చేయాలి అనుకోవాలి కాబట్టి ఫస్ట్ ఏం చేయాలి, రిఫైన్ చేయాలి అనుకున్నప్పుడు ఫస్ట్ వీ కెన్ చూస్ అన్ ఆర్కిటెక్చరల్ ప్యాటర్న్. ఏదో ఒక స్టైల్ని మనం చూస్ చేసుకోవాలి అకార్డింగ్ టు అవర్ design. Okay, that satisfy the architectural drivers, create the patterns based on the statistics and then we use it to achieve the drivers. Identify child modules required to implement the tactics. Okay, now tactics means design decisions. Okay, now we want to implement the design decisions, so we need to identify the child modules. Okay, now that is called sub modules, as I said. Okay, entire the system ni manam here we can select one pattern, one style to design the architecture. According to that we can apply the statistics according to the drivers. Okay na. So meanwhile we can divide those modules into చైల్డ్ మాడ్యూల్స్. అందులోనే మళ్ళీ మనం సబ్ టాస్క్ని ఎంచుకోవాలి. అదే కదా చెప్పాను, ద లార్జ్ ప్రోగ్రామ్ ఈజ్ గోయింగ్ టు డివైడ్ ఇంటూ సబ్ ప్రోగ్రామ్స్, ద సబ్ ప్రోగ్రామ్స్ ఆర్ గోయింగ్ టు డివైడ్ ఇంటూ sub tasks. So that is called an umbrella activity, that is called framework. So where we required, the module required another child modules, this is necessary to divide these modules into other sub modules. So that is called child modules. Why we divide them into means to better control, for the better control. That's why we can focus on the child modules to require implement the statistic. మన డిజైన్ డెసిషన్స్ అప్లై చేయడానికి we need to divide the sub modules also. We can focus on them. Then how we can refine, this is the first way. In this we are having another point. Instantiate modules and allocate functionality from use cases and represent using multiple views. So here we can, while designing them, so we can focus on the use cases. So use cases means what ma? Object oriented approaches. Okay na? That is called rational approach. That is called rational approach. Okay na? So we need to consider these use cases. So based on that we can view the multiple views. We can view the multiple views. Okay na? So use cases means tells what ma? The use cases tells about relationship among the end user with the particular system. That is any system, is a client system, is a server system, is a ATM system, whatever it may be, it is a system, either it is software system. Here according to our example. So like this we can mainly focusing on use cases here. So define interface, the next step, define interfaces to the child modules. So through the particular use cases we can define the interfaces to the child modules. Main module నుంచి child module కి ఎలాంటి ఇంటర్ రిలేషన్షిప్ అనేది మనం ఫోకస్ చేయాలి. సో దిస్ డికంపోజిషన్ ప్రొవైడ్స్ మాడ్యూల్స్ and constraints on the type of modules interactions. So this is the decomposition. Modules going to be sub modules or child modules. What is this? This is a decomposition. Okay na? This decomposition provides modules and constraints on the types of module interactions. As I said, so relationship, interaction is nothing but what ma? Relationship among them. Document this information is interface document for each module. Okay na? That is, you can interface the each module. So next point, verify and refine use cases and quality scenarios and make them constraints for the child modules. వెరిఫై చేయాలి, యూస్ కేసెస్ అనేవి ఎప్పుడు మనం ఏం చేయాలి, వెరిఫై చేస్తూ ఉండాలి, రిఫైన్ చేస్తూ ఉండాలి. వెరిఫై అండ్ రీడిఫైన్. ఓకేనా? రిఫైన్ మీన్స్ రీడిఫైన్ అని. ఓకేనా? వెరిఫై అండ్ రీడిఫైన్ యూస్ కేసెస్ అండ్ క్వాలిటీ సినారియోస్ టు మేక్ దెమ్ కన్స్ట్రెయింట్ ఫర్ చైల్డ్ మాడ్యూల్స్. ఓకేనా? చైల్డ్ మాడ్యూల్స్ కూడా ఇంటరాక్ట్ అవుతాయి కాబట్టి సో వీ కెన్ ఆల్వేస్ వీ కెన్ వెరిఫై ద యూస్ కేసెస్ వైల్ డిజైనింగ్ అండ్ అకార్డింగ్ టు వెరిఫై వీ కెన్ రీడిఫైన్ దెమ్. So and quality scenarios, according to we can focus on quality scenarios from the constraints of child modules. So like this we can refine. This step verifies that nothing important was forgotten and prepare the child modules for further decomposition or implementation. సో ఈ దీని మీద మనం ఎక్కువ ఫోకస్ చేయాలి అంటే చేయాలని స్ట్రెస్ చేసి చెప్పం, కానీ చేయడం వల్ల ఏమవుతుంది మనకి, వాట్ ఈస్ ద మెయిన్ యూజ్ ఆఫ్ దిస్ డికంపోజిషన్ ఆఫ్ చైల్డ్ మాడ్యూల్స్ ఈజ్ నథింగ్ బట్ సో ఎనీ for implementation is a better further development. That's why we can verify and refine the use cases again and again to better quality. Repeat the steps above for each module that needs further decomposition. ఈ స్టెప్స్ అనేవి మనము ఒక మాడ్యూల్కే మనము అప్లై చేయడం కాదు, మన లైఫ్ స్టైల్ ఆర్కిటెక్చర్ లైఫ్ స్టైల్లో ఉన్నటువంటి ప్రతి మాడ్యూల్ మీద ఈ స్టెప్స్ మనము అప్లై చేయాలి. ఏంటి? ఫస్ట్ స్టెప్ ఏంటి? చూస్ ద డికంపోజిషన్. So next, refine the modules. Refine the modules. Refine the modules లో మనం మళ్ళీ అదే స్టెప్స్ ఉన్నాయి. ఓకేనా? చూస్ అండ్ ఆర్కిటెక్చరల్ ప్యాటర్న్స్. నెక్స్ట్ వన్, ఇనిషియేట్ మాడ్యూల్స్ అండ్ allocate functionality from the use cases. Next one, refine interfaces of the child modules. Define interfaces for the child modules. Next, verify and refine use cases and quality scenarios. So, next repeat the steps above for each module to get need for further decomposition. So, that is the main importance of designing. We can observe each stage, we can observe each stage sub levels, sub tasks. So, we can refine, so with the help of use cases. So, why we can focus on main use cases while designing? The first diagram in the UML is use case. So, what it will defines? So, it says the interface among the modules, it states the interface among the sub modules. It says the interface is nothing but relationship among the user and system. It says the relationship between either it is the associativity, either it is a dependency. We are having different types of interfaces, different types of relations. So, for this we can mainly refine or we can mainly define the use cases. Always we can each and every step, each and every module or sub modules we can verify and redefine the use cases. That is very important. When we make a perfect use cases, so the design will be perfect, the quality will be perfect, the functionality will be perfect. That is why we can follow these steps. Yes? Then the first one, choose the module decompose. Manaki ADD steps lo first one entema, choose the module decompose. Ade kada. So, what is this? We can explain detailed here. Okay na? So, the following are modules. What are those? As I said in the previous system, when we saw the software system entirely once according to our concern, that is a module. Or when we divide this system into different parts or different modules or different units or pieces, whatever it may be, those are called subsystems. When you are going to divide the modules into child modules, those are called submodules. Okay na? Here the following are the modules, either it is a system, either it is a subsystems or a submodules. Okay na? Here we need to follow these 2 points. The decomposition typically starts with the system, which is decomposed into subsystems, which are further decomposed into submodules. The system is going to divide first, then it is going to divide into subsystems. These subsystems are furtherly divided or decomposed into submodules. Those are called child modules, as I said in the previous. Okay, now that is like this. We can, based on this concern, we can decompose the system, either system wise, either module wise, that is called subsystem wise, either child module wise, that is nothing but submodules wise. Okay. In our example, whatever real time example you have taken, what is that? Garage door opener is a system. Okay na? So, garage door opener is the system. Here the person is not directly open the door and close the door. The person using some device to open the car garage door or to close the garage door, that is nothing but to raising the door to lowering the door. One constraint at the level is at the opener must interoperate with the home information system. Okay na? General ga the person want to operate this car garage system at home information systems, okay na? Or otherwise switch or otherwise remote wise. So, that is called decomposition. Next, choose the architectural drivers. 2A lo first point into refine modules lo choose the architectural drivers. The architectural drivers are the combination of functional and quality requirements. Here the main drivers is nothing but here the technology. Here the drivers are nothing but here is the technology, which type of technology we are using, which type of patterns we are using, which type of statistics we are using here. So, that is called drivers here. Okay na? So, the architectural drivers are the combination of functional and quality requirements that shape the architecture or the particular module under consideration. Why we can combine these functional and quality requirements, why we can treat it, these are the two drivers for architecture, means these two can shape the architecture. When these two are perfect, automatically these two can shape the architecture. Combination of these two is a software architecture. It is a shape. That is the meaning of this sentence. is a module for under consideration. The drivers will be found among top priority requirements for the modules. Okay, first we can focus on top priority requirements of the modules. So, in our example, the 4 scenarios we have shown are architectural drivers, car garage system example. Dozens of quality scenarios, examine them. We see a requirement for real time performance and modifiability to support product lines. We also see a requirement that online diagnosis to support it. All of these requirements must be addressed in the initial decomposition of the system. Okay, now the second response. So, when a abstract is detected, may not seem like a tight deadline, but we are discussing a mass market where using a processor with a limited power translate into substantial cost savings. Also, a garage door has a great deal of interior and difficult to stop. Okay, now, for example, we can see this system. So, next, the determination of architectural drivers is not always to top down process. Okay, now, here we can mainly focus on top down approach, bottom up approach and object oriented approach. Okay, now, not only on top down approach. So, here also same top down process. So, sometimes detailed investigation is required to understand the ramification of particular requirements. So, when we diagnose these problems, definitely we will understand some problems. So, based on the problems we can resolve the particular problems. So, that is called ramifications to the particular requirements. Next, for example, to determine the performance is an issue for particular system configuration. Is a protocol implementation of piece of system may be required. In our example, determining the performance requirements is an architectural drivers required examining the mechanism of garage door and speed of the potential processors. So, very important here the speed of the potential process here. So, here we can see the decomposition process for each and every module according to the architectural drivers. So, other requirements also apply to the particular modules, but by choosing the drivers and also we are reducing the problem to satisfying the most important ones. And also we can focus on all the constraints of the most important things are the significances of ADD. Significances of ADD between the other architectural design methods. Okay, now we have to follow these steps when you are following, we want to design the architecture. Next one, choose an architectural patterns. So, next one, architectural patterns ni choose chesukoవాలి. So, which type of architectural patterns we can choose? So, here we can pick any style. So, first we can focus on, so here this seems like class diagram actually. So, first we can drivers mainly depends upon what functional drivers and functional and quality attributes. So, here we can mention them. So, how we can operate them, how we function them. So, that is mainly the view, the concern of user interface. So, the all are related to the user interface. So, here the user always be perform non-performance computations or performance critical computations and a non-technical wise and technical wise. So, anything, these are all different types of functions is related to the user. So, this is a virtual machine or this is a scheduler that guarantees deadlines. So, now the virtual machine nunchaina he want to be performing, so according to the deadlines. So, whatever this the user is going to interact the particular virtual machine. So, imagination, it is having different types of stages. Internally the virtual machine is nothing but, so internally it is having, it is done their own designs. Okay, na? So, either it is a non performance or performance wise. So, like this we can follow the constructions. Again we can follow the architectural pattern utilizes the first level decomposition of a garage door opener. So, ఎలా మనం డికంపోజ్ చేస్తాం దాన్ని అంటే ఫస్ట్ మనం ప్రాబ్లమ్స్ని ఇలాంటి ప్రాబ్లమ్స్ రావచ్చు అనేటువంటి టెస్టింగ్స్ డయాగ్నోసిస్ ఉంటాయి. సో, ఆ ప్రాబ్లమ్స్ రైజింగ్ ఆర్ లోవరింగ్ ద డోర్ సో మనం రైజ్ చేయొచ్చు, లేకపోతే లోవరింగ్ చేయొచ్చు యూజర్ అనేవాడు ఎవరైతే ఉంటారో. And abstractals detection. So while performing this function, any abstractals are came, we can detect them. For detecting, we can follow some functions. This is the actually this is class diagram. The symbol is nothing but a class diagram. Dini class diagram anochu, like the subsystem anu kuda anochu ee symbols ni. Okay na, here we are having some functions. Okay na, we can operate some functions, so we can design them while operating this. So how we can abstract till scheduler that guarantees the deadlines. సో మనకంటూ ఒక డెడ్ లైన్ పెట్టుకోవాలి విత్ ఇన్ ద ఫ్రాక్షన్ ఆఫ్ సెకండ్స్లో కానీ, లేకపోతే విత్ ఇన్ సెకండ్స్ 10 seconds ఆర్ 20 secondsలో కానీ మనకు ఆ ప్రాబ్లం అనేది డిటెక్ట్ చేయబడాలి. సో ఆ ప్రాబ్లం అనేది మనకి ఐడెంటిఫై చేయాలి, దాన్ని మనం టెస్ట్ చేయాలి, డయాగ్నైజ్ చేయాలి. సో వైల్ రైజింగ్ అండ్ లోవరింగ్ ద డోర్స్. So these are all having interrelationship with the communication virtual machine. Okay na, the main thing here, the user communicate having the main function, so is also be communicate with the this particular virtual machines, and also sensor actuate virtual machines, and also we are having some sensor machine signals, and also scheduler that guarantee deadlines. Okay na, these all functions ఒక గ్యారేజ్ సిస్టమ్స్ మనం డిజైన్ చేయడానికి వీ కెన్ వ్యూ దీస్ ఆల్ టైప్స్ ఆఫ్ ఫంక్షన్స్ అండ్ క్వాలిటీ రిక్వైర్మెంట్స్. ద యూజర్ ఈజ్ interact with this particular all type of sub modules. So like this we can design the architectures. Okay, now when the user interact with the system, so how he is interact, which type of problems will be occurred, how to diagnose that, how to identify the abstractals, how to detect the abstractals. So in particular schedule of time we can resolve the system, how it will restart it. So what is a virtual machine, so what the virtual machine having these internal functions, this all we can design according to these thoughts. We can design the architectures. Okay, now this is a better example for garage door system. So here represent the architectures with views. Okay, now then we can represent the views, architectural views. So we are having different types of views: modular decomposition views, concurrency views, and starting up the system and shut down the system. Manaku telisinde kada module decomposition views. Okay na, concurrency views. Here two users doing similar things at the same time. ఒకవేళ కార్ గ్యారేజ్ సిస్టమే మనం కన్సిడర్ చేసినట్లయితే టూ యూజర్స్ డూయింగ్ ద సిమిలర్ థింగ్స్ ఎట్ ద సేమ్ టైం. అంటే ఎలాంటి ప్రాబ్లమ్స్ రావచ్చు ఈ సిస్టమ్స్లో అంటే, వస్తే టూ డిఫరెంట్ పర్సన్స్ అన్నోయింగ్లీ దే ఆర్ డూయింగ్ సేమ్ థింగ్. ఏంటి అది అంటే, దిస్ హెల్ప్స్ రికగ్నైజ్ రిసోర్స్ contention or data integrity problems. So in our garage door example, one user may be closing the door remotely while another is opening the door from a switch. ఇక్కడ 3 అప్రోచెస్ ఉన్నాయి కదా కార్ గ్యారేజ్ సిస్టమ్ ఓపెనర్ సిస్టమ్కి. ఒకటి త్రూ స్విచెస్ ద్వారా మనం ఆపరేట్ చేయొచ్చు, త్రూ రిమోట్ కంట్రోల్ ద్వారా మనం ఆపరేట్ చేయొచ్చు, త్రూ హోమ్ ఇన్ఫర్మేషన్ సిస్టమ్ ద్వారా చేయొచ్చు అని చెప్పాం. ఇక్కడ ఈ ఎగ్జాంపుల్లో ఎలాంటి జనరల్గా మనకు ఆర్కిటెక్చరల్ డిజైనింగ్ ఎలాంటి ప్రాబ్లమ్స్ రావచ్చు అంటే, అకార్డింగ్ టు అవర్ రియల్ టైమ్ ఎగ్జాంపుల్, కన్సిడర్ 2 persons. These 2 persons unknowingly, one person is going to close the door remotely. He want to close the door, garage door. So at the same time another person unknowingly he want to opening the door. Endukante these 2 persons are stayed somewhere else. Okay, they are not saying they want to, somebody want to open, somebody want to close. In this situation the system is going to be stuck. The system is going to be stuck. But when it will comes to normal, within a fraction of seconds it's going to be restart again. So this type of obstacles we need to resolve in a particular architectures. So automatically within the fraction of seconds is going to be restart. Okay na, this type of problems, this types of obstacles is going to be comes in a particular architectures. So we meanwhile we are going to resolve them. So based on this consideration of these all constraints, according to that they need to design the architectures. And also in our performing multiple activities simultaneously, ఒకవేళ ఒక పర్సన్ మల్టిపుల్ యాక్టివిటీస్ని సైమల్టేనియస్గా పెర్ఫామ్ చేయాలి అనుకున్నప్పుడు దిస్ హెల్ప్స్ టు అన్కవర్ డేటా ఎక్స్చేంజ్ అండ్ యాక్టివిటీ కంట్రోల్ ప్రాబ్లమ్స్. ఇన్ అవర్ ఎగ్జాంపుల్, ఏ యూజర్ మే బీ perform diagnostics while simultaneously opening the door. Okay, that is another problems will be came. Okay, now starting up the system. This gives a good overview of permanent running activities in the system and how initialize them. So మనం ఎలా it initialize చేయాలి according to these coming problems, how we can resolve. It also helps in deciding on an initialization stage, such as everything in parallel or everything in sequence or any other model. So ఇలాంటి ప్రాబ్లమ్స్ మనకు రాకుండా ఉండాలి అంటే సో వీ కెన్ సెట్ దెమ్. సో ఎయిదర్ వీ కెన్ అలౌ ద ప్యారలల్ processing or either we can allow the sequence processing or any other model. Okay na, parallel processing means many members will operate. Okay na, so ila manam future constraints kuda drishilo pettukoni we can apply either everything in a parallel processing or sequential processing or any other model. In our example, does the startup of the garage door opener system depends on the availability at the home information system, or is the garage door opener system always working waiting for the signal, or is it starts and stopped with every door opening and closing? So then we need to get the signals. Okay, either it is closed, either it is open. So like this we can design. And ela manaku telustundi ante according to the particular device, what is the device they are designed to operate this particular either switch wise or either remote wise either home system. One signal is blinking. Okay na, when it is off it is in inactive mode, when it is on it will be blink. Like this they are going to be designed. So according to our CPU, okay na, so when we are start this CPU, it will having lighting. Okay na, when we off the CPU button, automatically the light is off. So we know that it is the on and off mode. Like this also the system is going to on, the system is going to off, we need to able. Okay, it is able mode or unable mode, it is unable mode or able mode. Okay na, so that is active mode, inactive mode. So based on this they can design the systems. So next, when we want to shut downing the system, so start the system or shut downing the system, it helps to uncover issues of cleanup such as achieving and saving consistency of the state. Okay, 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 that is, and everything one system is going to design, we can focus on module decomposition view, we can focus on concurrency view. Concurrency view lo manaku vachetటువంటి problems, okay na, multiple users they are doing unknowingly same activity at the same time, so we will get the different problems, we can resolve those problems. Okay na, how we can resolve them, and also we can allow to avoid those obstacles, we can allow the process either parallelly, either sequentially or other modes we can apply. So we want to start the system, we want to shut down the system, everything will be in the particular clear details. Like this we are going to design the systems. And then development view. So not only these about two views, okay na, development view is also very, deployment view is also very important. The deployment view also helps in deciding if multiple instances of some modules are needed. For example, a reliability requirements may focus up to duplicate critical functionality on different processors. A deployment view is also support reasoning about the use of special purpose hardware. So this is the way also focusing on hardware, not only the interface, we can also focus on hardware. So when we are going to view this deployment view, we can test either logical view or either physical view. This is the more important in the deployment view. Okay na, that is the main thing we have to follow. Then the second third bit, define interfaces of the child modules. Okay na, we can define the interfaces for the child module. For purpose of ADD, an interface of a module shows the several and properties provided and required. This is different from the signature. It document the other can use and on what they can depend. So we can need to document according to the particular design. So according to different signatures, how we can document, how we can dependencies are having, everything is going to be document. Analyzing and document the decomposition in terms of structure. ఓకేనా, మనం అనలైజ్ చేయడం కానీ డికంపోజిషన్ చేయడం కానీ దట్ ఈజ్ ఇన్ టర్మ్స్ ఆఫ్ ఏ స్ట్రక్చర్ మాడ్యూల్ డికంపోజిషన్ వ్యూ అండ్ డైనమిజం కాన్కరెన్సీ వ్యూ అండ్ రన్ టైమ్ డిప్లాయ్మెంట్ వ్యూ. ఓకేనా, దిస్ బేస్డ్ ఆన్ దిస్ వీ కెన్ uncovers the interaction assumptions of the child modules which should be documented in their interfaces. So that is it. Next one, the module view documents. The module view documents. Here we are having producers, consumers and information, patterns of this, patterns of interaction that requires modules to provide services and use them. Okay, now we can focus on different types of views here. Next, the concurrency view document. In the concurrency view document, we can have interactions among the threads that lead to the interface of a module providing or using services. The information that component is active, for example, has its own thread running. Okay, na? The information that is a component synchronize, sequentialize and perhaps blocks calls. ఓకేనా, మనకి సింక్రొనైజేషన్ జరుగుతుందా, సీక్వెన్షియలైజేషన్ అంటే ప్యారలలా, సీక్వెన్షియలా, లేకపోతే పర్ఫాక్ట్ ఇది బ్లాక్ అయిపోయిందా ప్రాసెస్ అనేది, ఎవ్రీథింగ్ విల్ బీ ఇన్ దిస్ వీ కెన్ ఫోకస్ ఆన్ డిజైనింగ్. ఓకేనా, నెక్స్ట్ వన్, ద డెవలప్మెంట్ వ్యూ డాక్యుమెంట్స్. So we can focus on development view documents. Okay, na, hardware requirements such as special purpose hardware, some timings requirements such as that composition speed of a processor has to be at least 10 MI, and also communication requirements. Everything is going to be focused on deployment view documents. So then we can verify other things, verify and refine. Functional requirements. What are the functional requirements? User interfaces, raising and lowering door modules, abstract detection, communication virtual machine, sensor or active virtual machines and scheduler diagnosis. So these are steps we can discuss in the next class. So here we are discuss some of the steps regarding to the ADD, how we can design the software architecture with the help of attribute driven design method. So what is the first step? So what is the next steps? How we can refine them? So based on that, how to we can apply the statistics on each and every module, how to define the, how to decompose the total system into subsystems, how we can decompose the subsystems into submodules. So based on we can recursively we can apply these all steps in each and every module. So that is called designing actually of a particular architecture to get better quality and functional requirements. These quality and functional requirements both are give the shape to the particular architecture. That's why we can call them, these two is a architectural drivers. Okay, I hope all you understood. So we can continue the remaining part in the next class. Okay. All you stay, I will take the attendance. Hello, who are talking together? Hello, ఎవరండి మాట్లాడుకుంటున్నారు? హలో,
సరే కానీ కాలేజ్ పెట్టిన ఆప్షన్ వచ్చింది, నియర్ బై కాలేజ్ ఎక్కడైనా పెట్టుకోవచ్చు. నువ్వు ఎక్కడ పెట్టుకున్నావు?
11:45కి మీకు ఎంఎస్ క్లాస్ ఉందండి. ఆల్ ఆఫ్ యూ అటెండ్ టు ఎంఎస్ క్లాస్ ఆల్సో.